Welcome to the Lightning Talks. So we have a session that will comprise several small sessions. Everyone will be a maximum of 5 minutes. We have a timer on our right side, and the timer will start at 5 minutes. When the timer reaches 0, the speaker will stop speaking and leave the place to the next one. I will encourage you to remind the speaker of the time by counting out loud from 10 seconds to down to 0. It will keep the rush going, so the speaker will be encouraged to be fast. So the first one will be Evan Elias, a modern approach to schema management. Take it away, Evan. Right, left.
Great. The slides are already loaded after this? Yes. Hello, my name is Evan Elias. I'm an independent MySQL consultant. Previously, I've been a database engineer at Facebook and Tumblr. Today, I'm talking about schema management. As a consultant, I've been talking to a lot of companies, and I'm seeing something a little scary these days. Among smaller companies and startups, a lot of them are not opting to use MySQL. I'm seeing a lot of Mongo, a lot of Postgres, not a lot of MySQL. There's a few reasons for this, but a big one is the complexity of schema changes in MySQL. This makes sense if you think about it. If you're starting a new company or a new product, you're going to need to be iterating on your schema quite rapidly. So you're naturally going to choose a database that makes that easier. So what can we do about this? Well, MySQL 5.6 added a great feature. It's online DDL. This gives you the ability to alter a table without locking the table. Awesome feature, one huge problem with it. If you go to alter a large table and that alter replicates, you're going to get a ton of replication lag. Slide got cut off a little bit here. But so basically, you can just use SQL log bin equals 0 and avoid replicating the statement. And basically, you can do the statement just on the replicas and then do it on the master. This is great unless you use RDS. So RDS does not give you a super user. You cannot use set SQL log bin equals 0, so you can't do your schema changes this way. An alternative would be to use PT Online Schema Change. This is an awesome tool from Percona. Allows you to basically do online schema changes without any table locking and without any replication problems. Great tool for DBAs. Back-end engineers are usually fine with it too. I mean, it's a command line tool. You're using it manually. The problem, though, is that product engineers, full stack engineers, usually you don't want them monkeying with this by hand. It's a little scary. And the product engineers are the ones who need to change their schemas most rapidly anyway. A couple other little issues with PTOSC. It only solves altering tables. I mean, dropping and creating tables is trivial, but basically you're going through a different process to do that. So PTOSC, although it's an awesome tool, isn't an all-in-one solution. Another option, a lot of MVC toolkits, frameworks like Django and Rails come with migration systems. These are just no good in MySQL in general if you have any reasonably sized tables. They won't use online DDL. They use a very odd abstraction that kind of represents a diff in your programming language. There's a lot of continuous integration and deployment systems out there, but these don't really solve the problem either. They're mostly based on code. So what would a system look like that was taking the concept of continuous integration, but instead designed for schema changes? So in my mind, this would look like you have a Git repo and you have a very tight mapping between files in a Git repo and schemas. So you can have some arbitrary directory structure of different directories for different schemas or different database instances. But within each of those directories, you have a bunch of .SQL files that each contain a single create table statement. And you want a system where to create a new table, you just add a new file. To alter an existing table, you just edit that file. And then you go through whatever your normal Git workflow is for code review and pull requests. So you have a system that basically can diff those changes to those .SQL files and figure out what the corresponding alter is, and then figure out the right way to do that alter. So if it's a small table, it could just use online DDL, or if you have no replicas, it could use online DDL. But for a larger table, use PTOSC. And you can get more complicated with this too and have a mapping between other branches. So you could say that you have a staging branch in your Git repo. When you merge to that, it'll automatically update your staging database. Similar with dev databases, basically support an arbitrary mapping. And then integrate with as many things as possible. So make it easy to work with RDS, easy to work with GitHub, popular ORMs. So I've been working on a tool that does this. Sign up for the mailing list, www.schema.net. Thank you.
Thank you. So the next one will be Stewart Smith. The 5-minute introduction to MySQL and MariaDB on Power.
Thank you. Excellent. So this is the 5-minute version of my talk I gave yesterday. So I'm going to attempt to do it in a lot less time than it was. So I'm talking about the Power CPU architecture. And of course, pictures of CPU dies are always cool, so I included one of those. What do I mean by CPU architecture? Surely this does include the instruction set and the memory coherence model in SMP systems, but it also is kind of intimately involved in the implementation of the silicon as well. So of course there are different chips that implement the same instructions and so are binary compatible, but execute them a lot differently. Thus, each new generation of chips runs the same software faster, we hope, is always the thing in hardware design. You're probably aware of some other CPU architectures that are fairly common. You probably have an x86-64 box, an ARM box, and a MIPS box. ARM is likely in your pocket. MIPS is possibly in your router, and x86-64 is probably your laptop. So why would you use Power, and specifically the current generation of Power processors, which is Power 8? So Power 8 is a first processor that ran 1 million SQL queries per second for MySQL. That's what I spoke about last year. So it is a high-performance processor. It is a RISC architecture. It has lots of cool things here. So if we bring up the wonderful slide that is involved, all the magic things inside a chip, we do up to 12 cores per socket. So each individual die can have 12 CPU cores. Each of these cores can run up to 8 simultaneous threads, so it's SMT 8, and that's configurable at runtime. So you can just at runtime change up or down between single-threaded and up to 8 threads. There is a whole bunch of instruction dispatch and issue and exec pipeline stuff there. 64K data cache and instruction cache, which is a pretty large amount of cache there. We're really keen on L2, L3 caches and the like, so we've got 512K L2 cache per core, 96 megabytes of shared L3, and the Power 8 chip actually has the memory controllers off the side of the die, and they have further L4 cache before you even get to DRAM. We have an incredible amount of memory bandwidth, so up to 230 gigabytes per second of sustained memory bandwidth, depending on the configuration of the machine, which is a lot. So when you have workloads that access memory a lot, for example, your database is probably a lot of stuff in memory that you access a lot while running queries. That gives a bit of a performance advantage going there. The way we do SMP is also pretty interesting. So we scale out to many cores. Once you get 12 cores per socket, suddenly a 2-socket machine is 24 cores. Then you do 8 threads per core, multiply it out, and suddenly you have 192 concurrent threads executing on a single 2-socket box, which is relatively small. We're really keen on also having interesting accelerators, so we have ways to coherently attach things there. One unique thing about the Power architecture is that we have the Open Power Foundation. So this has come about to, instead of have sort of large proprietary stacks and proprietary firmware, we have open source firmware. As in, you can download the source code to the first instruction the CPU core executes. This is before DRAM works, before thermal limits are on, before we're enforcing power requirements and the like. It up right through your Linux, your OS, and database server. We also have OpenBMC, so on some machines now we're also having a completely open source stack on the BMC, so you're starting to have a machine that does not run any proprietary software that you can't go and poke at and that you can't trust. We are really good in the virtualization department, so the Power hardware has for a long time done really good virtualization and partitioning. So if you run CPU-bound and memory-bound workloads on a Power chip, we cannot measure overhead of virtualization. Right, it's within the noise of running a benchmark, and this is with real MySQL running like sysbench workloads. It basically then comes down to the overhead of how you do your I/O. So if you do PCI pass-through, of course, it's going to be different than if you're doing, pass-through to a QCOW2 image on a file system. But we have a really low overhead virtualization to really do density, and when you start to over-commit the CPU resources in the machine, we sort of degrade gracefully and have really good balancing out there. So this is really good for VM density. You can also run, of course, many things concurrently, 192 threads per 2-socket box, but putting a lot of virtual machines onto a single box also works really well. We have reliability and serviceability. Everything inside the Power chip has checksums and will report errors back, so the whole idea of design is to never act on bad data. So you will get checksum errors and corrections there. If an L2 cache line goes bad, we'll mark it out at runtime and continue. We can do all sorts of fun things there with error detection and recovery, including resetting PCIe cards even at runtime. Current status is MariaDB is officially supported, has been for a very long time, so I think even back to 5.5, 10.0 is definitely there and works pretty well. MySQL is in tree, plus a couple of patches currently needed. Percona server not there yet. Getting hardware as a service from these guys, and no questions because it's a lightning talk.
Thank you, Stewart. All right, so the next one is Alkin, building a DBA as a global team.
Okay. All right, thank you. My name is Alkin, and I'm going to talk about kind of a non-technical talk to build a team around, for your support. So team size and the skill set, you want to have a, two-piece rule, not a large team, not a very small team, especially for a DBA team. For a coverage perspective, between 5 and 12 people teams that worked best for me, but the optimal number was 8 to 10 people doing a global support. So depending on the workload and depending on the internal or external customers' requirement, you might want to have a larger or smaller team. Smaller teams for specific projects work the best. Geographic locations, talk about the time zones. So in US West and East work the best. Europe and APAC actually optimal. If you're doing a follow the sun model, you're going to have 3 different time zones at least. So 2 or more time zones, the best. It actually helps DBAs to have some break, personal time off and vacations, stuff like that. This is an actual on-call schedule implemented by my team, multiple time zone, different places. This is 4 different time zone, two each in 2 DBAs in each time zone, having a great coverage, 6 hours on-call shifts, and less frequency in the weekend on-call also. Having this implementation will require at least 8 DBAs. Probably you're going to have 1 spare DBA for project work, another specific, escalation procedures. But if you, of course, this is like optimal. But if you can't reach there, at least have minimum of 2 different time zones availability. This is something I have implemented in my teams in the past, and also I have practiced in the past. Of course, it's not my invention. This has been buddy system has been practiced in militaries for many years. It allows DBAs to collaborate, brainstorm, share, and also offload some work, and it gives flexibility. The more the DBAs are flexible, the better they perform. So having at least 2 or 3 DBAs in each time zone will allow you to have flexibility and get some more performance out of them. Promoting a teamwork. Of course, if the team is working like a team, that we can call it a team. You have to promote the teamwork. It's part of the buddy system. As people collaborate in each time zone, they will be able to go in and help the others in different time zones and different projects, and then that will bring better work environment and longer retention, to be honest. Keeping track of KPIs, of course, you need to keep track of your pages, tickets, and the load on the DBAs. If you have these numbers, you can plan ahead. Remember, hiring a DBA and ramping up will take a long time, so keeping track of numbers is a good idea. Tools and utilities for collaboration. Not every tool in the market works for every DBA. We have a lot of tools designed for developers, and then we adopt them to DBAs, but sometimes they don't work. So we have to tailor and then customize some of the tools for DBAs to work. If you have the right tools, they will share. If you don't have the right tools, they will do it their own, and there will be no documentation about the work that they do. Team building, of course, promote teamwork, promote conferences like this, and have people come over and share. And doing a local or remote mashups will always help. Visit them, have them collaborate, and actually feel that they're working in a team. Thank you very much. That's all I have.
Thank you for the speed. So the next one is Vishnu Rao, Storm Wars Episode 7.
Hello everybody, I'm Vishnu. I'm a Jedi at PocketMath.com in Singapore. So today we're going to have a look at Storm Wars Episode 7, when the data stream shrinks. So Apache Storm is a stream processing framework. It's used to pull data from a stream and perform real-time analytics on top of it. So a stream can be Apache Kafka, as we know, Amazon Kinesis. A stream has multiple partitions. This is for better read and write throughput, normally. So when it comes to partition has metadata around it. So Storm generally uses integers to identify a partition, 0, 1, 2, 3. But Amazon Kinesis, for example, uses strings to actually identify a shard. So how can we actually process data? Because we have integers and we have strings. So normally what the user does is he actually sorts the strings and then assigns the sorted items to integers. So for example, you'll have shard 001 mapping to 0 and shard 002 mapping to 1. So if you look at the Storm API, it clearly mentions that partition is an integer, but in Kinesis it's a string. So here's an example of you have a Kinesis stream, and it has one partition, shard 1, and Apache Storm is actually pulling data from it. So here the metadata would be 0 maps to shard 1, and Storm would be processing data accordingly. So in Amazon Kinesis, you have an API called split, where you can actually split a shard into two child shards. So in this case, if I split shard 1, I have 2 children, shard 2 and shard 3. So a total of 3 shards appear right now. So this is the case where the stream actually expands. But if you notice, the metadata is still the same. 0 still maps to shard 1 over here. Now, this is very particular about Amazon Kinesis. What Kinesis does is, AWS, they actually delete the parent shard after 24 hours. So what actually happens is, now you have 3 shards suddenly becoming 2 shards. This is where the stream actually shrinks over here. And if you notice, the metadata is still the same. 0 maps to shard 1. So as Yoda would actually say, there's some sort of disturbance here with regard to partition metadata. So if you notice, since the stream has actually shrunk, shard 0 is no longer there. So the metadata is actually invalid. The new metadata should be shard 2 points to 0 and shard 3 points to 1 over here. So solution would be just create a simple whitelist. So in Storm, you have this notion of a Storm topology. Every Storm topology can now be configured with a whitelist of particular shards. So in our case, if you take topology 1, set a whitelist of shard 1, then you split the shard, start topology 2 with another whitelist of shard 2 and 3. So in this case, shard 1, when it gets deleted, the topology dies with it. But topology 2 continues processing data irrespective of topology 1. So if you notice, there's no metadata conflict over here. Everything keeps going because there's no conflict, and Storm is happy, you're also happy. So as you would say, now the balance has been restored in some sense over here. So that's it. Thank you, and may the force be with you.
Thank you. So the next one will be Michael Wang, MySQL Schema DDL Comparison.
Hello, everyone. I'm Michael Wang. I work for Salesforce. And today I'm talking about schema comparison. I'm talking about a program idea, how to do this, and this the synopsis for how to do the tool. And you specify server 1 with user, password, host, and port number, and server 2. And server 1 is a reference schema. That's the truth. And you compare 2 against number 1 and find what's the difference and bring them together. And before I wrote my own tool, I tried not to write my own tool. I tried to look available tools. And one tool I use is MySQL diff, and the other one is from Redgate, the commercial software. And I found they could not do the job. The result is wrong. And this is just not to say bad word about the other people, just say why I write my own tool. And what I can see that why the other tool fails, because they try to compare the schema based on text, use diff. And the approach is bad because sometimes when the column order appears differently, they think, the two table definitions are different. So I try to avoid that. First, I try to get a table definition from a dictionary, and I load into a data structure, basically a hash import. And I build the program using different modules. First, compare tables and columns and index and foreign keys. That's the 4 modules I have. And what I need, we can add more modules if needed. So for the tables, it's easy to just build 2 hashes. If the column table, you don't do anything. If you have table missing, you just create a table. If you have extra table, you drop it. But this is the first step because based on this, you do the columns. For the columns, then you just go with the common table and then find the columns and the column definitions, and then compare the data structure, compare the hashes. And just to make my talk not too short, I'll give you an example. And here I have the site table, which is the parent table, and the email table, which is a child table, which reference the site table. So this is in schema 1. And this is in schema 2. I just have the email table. I don't have the other table. And in the red, that's a difference between the two. And you can see that the site ID, the reference table has unsigned, and here does not have unsigned. And for mailbox ID, is the reference table, the correct table is the integer 11. Here I have big integer. And for the message ID, default in the reference schema is now I have a empty, and also the index is wrong and there's no foreign key. So then I use the tool. So that's the command line, and the command line generates the output, and then it creates a missing table. And for the columns, it modified the columns to make them the same. So it's a pick up the column definition, the now signed, unsigned, pick up that. And for the indexes, it's drop the incorrect indexes and add a new index. And for the foreign key, it's found the missing foreign key and did that. And this end my talk, I'm interested to know that why other people don't have this problem and how they solve the problem. And for if you're interested, you can download the program from the GitHub. That's all. Thank you.
Thank you. So the next one up, it's me. And we are going to show you something about MySQL replication with containers. So what is a container? Container is a virtualization system that is not a virtual machine. Sometimes it may look like a virtual machine, but it's not. The difference is that it works close to the operating system and can only run on the same operating system as the host, at least for now. It's less secure than a VM, but is extremely fast to deploy. And is almost as efficient as a regular server. So, really, what is a container? Until I tried it, I didn't know what is it. I mean, I had the same feeling that I had the first time that I started using a scripting language instead of C that I used for 10 years to write system tasks, and then I told that myself that I was a fool. So let's see an example of MySQL replication in containers. Okay, now we are going to do something live here. I'm going to run 3 containers. What you see now in the screen are the deployment of the containers. This took less than a second each. Now we are waiting 10 seconds just for the server to be fully set up. Now we are testing every node to see if they are up, setting replication, and then we are running a simple test, creating something in the master, and we are going to check the slaves if they have it, and it's done. So the whole operation, starting 3 containers, setting replication, running a test, is more or less 30 seconds. And this I did on purpose to save time on the timer. Thank you. That was it. So now a real talk. Arthur will talk about invention, inventors, DBAs, and open source.
Okay, thank you. So, indeed, I'm going to talk about inventions, inventors, DBAs, and open source. So first of all, what is an invention? An invention is creating something new, a new process. The US patent law has a very broad description of what is an invention, because the more broad it is, the more patents they can create. But in other words, it's just create something new. What is an innovation then? What's the difference? Innovation is basically translating something like an idea into a new invention or a good or something you will pay for. And what is most importantly about an invention, it has to be economical and it has to satisfy a certain need. So an innovation and an invention are almost the same, and there's a really thin line between them. To illustrate this, an invention or innovation could be like the scissors. The scissors were invented like 1500 before Christ by the Mesopotamians, and all they did was just attach 2 bronze blades to each other. So the idea behind this is that an invention or innovation, the blades already existed. Someone else took that idea and then added a pivot point, added some handles. Is this an invention or an innovation? Could be both. Nowadays we have modern scissors, and modern scissors have improved grips. You can apply more force, you don't have painful fingers. Is this an innovation or invention? I would say innovation. You have pinking shears, clearly innovation. This is nothing new. You can just zigzag cut in a piece of paper. And then we can go even beyond that, and that's called a chindogu. And a chindogu is a Japanese term for an unuseless invention or innovation that actually goes beyond the practical use. And some other examples to illustrate, you would never buy things like this. Some famous inventors, Alva Edison invented the light bulb, but was this actually an invention or innovation? All the components that he used for the light bulb existed before. The computer, I would say it's a good invention, but it's making use of all sorts of other components that were used before. But the idea of the computer was new. Invention. Another one, computer game, using a computer to compete to a human. That was a new idea. So the conclusion is, basically if you have an invention, you do something that you haven't done before, while an innovation is you just improve an existing invention. Now the question is MySQL an invention or innovation? I would say it's innovation, and I'm going to step upon a lot of people's toes, but the databases existed already. Oracle was the first commercial one, Postgres had the first open source database, and MySQL was the first one to implement SQL. So I would say innovation, but where are then the MySQL inventions that I'm going to talk about? Well, Percona Toolkit, it's a really nice open source tool, based upon the Math Kit by Baron Schwartz. Never existed before and is helping us all. Galera cluster, well, MySQL replication exists, but they reinvented the whole replication system to a clustered open source tool. InnoDB Ruby, really nice way to visualize your data, find hotspots. Never has been done before, and Jeremy Cole invented something new. My Graffiti Ruby is my own invention. It's a work in progress. Basically, I'm creating a script that writes data to a database, and then you can write graffiti to it. Well, this is actually a chindogu. But you could be an inventor too. You can find new ways to use technology. You can contribute to open source projects, and you can create brilliantly new things. Some other resources that I use, Tech Laboratories, check it out. He has really nice videos on technology, and of course Wikipedia. Thanks.
Thank you, Art. Now we have one more talk that requires a change of computer. Are you set? Yeah.
All right, cool. So my name is Sandeep. I'm a developer advocate at Google Cloud Platform, and I'm talking about stateful data in stateless containers. So a little bit similar to the talk 2 talks ago. So let's create a MongoDB replica set with no manual configuration using containers. And then, is such a thing even possible? Why, yes. Yes, it is. So just to people who don't know about MongoDB too much, why use replica sets? Your app talks to MongoDB to store its data. MongoDB is web scale. It goes down. So instead, you have multiple replicas. So even if one goes down, you can talk to another replica, and your app is still happy. You get no downtime. Yay. So what I'm going to do is use MongoDB as my database, then Docker as my runtime to run that database, Kubernetes as my orchestrator to schedule these containers, and then Google Cloud as my cloud platform. Wow, I don't know about you guys, but that sounds pretty complicated. But you know what is complicated? The manual steps to deploy a replica set. So one, you provision your VMs because you can't run replicas on the same VM because failure domains. Then you have to provision your disks. Then you install MongoDB on each VM, and hopefully it installs. Configure MongoDB on each VM. Create your replica set. Initiate the master and the replicas by logging into prod onto each different VM and typing in commands. Hardcore a bunch of IP addresses into your config files, and because you're running on the cloud, these can change, right? You never know. Then you try to add another replica, forget you forgot something, pray your IPs don't change, pray your VMs don't go down, do something, and then you just give up, and then you use like Mongo Labs, and someone else can host it for you, and you're good to go. But that's silly. Why can't we just let computers do the boring stuff? So in the land of containers, this is all you have to do. Create a cluster, log into your cluster, clone some code, and basically all that is in this GitHub repo is 2 containers in something called a pod, which I don't have time to talk about. One is MongoDB. One is a little tiny Node.js script that just constantly pulls the service discovery built into the cluster and automatically configures everything into your replica set. And then I just run the add replica command 3 times, and boom, I have 3 replicas, and it's done. That's basically it. So what the heck did we just do? Docker lets you skip installation, right? So all of these steps are skipped because we're using Docker. So you know how to provision your VMs. You know how to install MongoDB onto each VM. You know how to configure it. It just kind of does it for you already. It's like a package. And then Kubernetes lets you skip all the configuration. So creating a replica set, initiating the master, hard coding the IPs, none of that stuff is necessary anymore. You just let Kubernetes do that for you automatically. So Kubernetes also lets you simplify the maintenance. So, oh my God, a replica crashed. What do we do? So in the old world, you'll get a Slack at 2 a.m. because everyone's cool and uses Slack. You try to restart MongoDB, try to reboot the VM. You hope the IP addresses didn't change. You reconfigure your replica set. If that didn't work, maybe you just spin up a new VM and try to launch MongoDB on that one instead and hope the data copies over. And then you wait for the data to replicate, and hopefully that all works. But again, you're doing this at 2 a.m. because things always crash at 2 a.m. But again, let's let computers do the boring stuff, right? So what happens here? You just sip on your tea, and then you discover that Kubernetes has spun up a new container with MongoDB in seconds, like we saw before, on a new VM, and the data disk is automatically attached to this new instance. And what I mean by that is because in a cloud, Amazon EBS volumes, Google persistent disks, all these things are just network drives, right? So you can just reattach it to a new VM, and it doesn't even realize that that data came from a different instance. It just gets reattached automatically. And Kubernetes is what lets you do all of that without touching anything in prod. And then you can watch more cat videos. Yay. So the best part is this is 100% open source. It works on-prem and in the cloud. One of my friends at Flocker did the same thing using a Cluster HQ's Flocker, which lets you do things like your own SAN and things, automatically talk to Kubernetes and configure itself. So I did all this on Container Engine. So you just get a one-click cluster. You don't have to set it up. On AWS, CoreOS has an awesome automatic tool. And it's not all magic. Read more here on how I actually did it. Thank you, guys.
Thank you, everybody. So this concludes the session because we had one more speaker, but the speaker disappeared. And eventually we will take revenge, but for now, we don't have anything more to show you unless you have questions, and all the speakers will be happy to answer.
Coming with the microphone.
Got it. Just, there was a lot of great slides, and that last slide on most people's presentation was not always easy to get. So is someone going to put these slides on a place where we can get them, or at least that last slide that has a summary?
I will put all the slides in Percona site. So depending on the speed of the internet, it will be there within half an hour, maybe.
Sveta Smirnova, question to Michael Wang. You showed this tool which compares tables, but I know you're interested in different tools. Are you planning to expand your suite, or it will be just one tool?
This I wrote first to satisfy my needs, but if you find something doesn't work or you need something else, we can work together. Yeah, my email is in the slide.
Okay, thank you.
Any more questions?
Can you show your slide, the script that you did for Docker containers? The script that you ran, the deploy script?
Yes.
Because you just spoke for 3.5 minutes. That 1.5 minutes is still pending.
Okay, I will. I will add the address for this script in the slides, because that script is in GitHub, so you can download it and replay it at will at home. You can deploy, if you have a bigger machine than my laptop, you can deploy 20 servers in more or less the same time that I did 3 servers. Okay, so thanks all the speakers for their bravery to come here and present in 5 minutes, and thanks to you for attending.